Okay, now let's take a look at the third phase of the data journey, analysis. Being the phase with the most variations in terms of implementation, there are also physical and digital ways to classify analysis methods. But the focus on their differences is more about what is being done with the data. And this can fall into many different categories with different ways of classifying them. For this lesson, we will be giving a brief introduction to Jeffrey Leake's 6 archetypical analysis: descriptive, exploratory, inferential, predictive, causal, and mechanistic. Descriptive analysis is the most straightforward of them all and involves simply illustrating the data set or highlighting certain aspects of it with little or no intermediary processing. Using the example of our weather sensor data sets, descriptive analysis would be obtaining the number of times it rained over a month and saying it rained 4 or like 5 times this month. Next, exploratory analysis looks at data sets and tries to discover new correlations between them. These correlations do not necessarily mean anything, but give us a better idea of where to start. For example, if we wanted to find out what potential causes there are for thunderstorms in a certain region, observing other values such as humidity or temperature in that region from before to after the storms might give us some clues as to what to check next. Inferential analysis is most commonly used when we are learning about statistics and is characterized by taking a smaller data set and using observations about it in order to describe its population. For example, if we observe the rain patterns of a few regions over a year and from that data try to guess what the rain patterns for all similar regions are like in general over a year. Next, predictive analysis is when we utilize the data that we have in order to try and, as the name suggests, predict what is going to happen in the future. These predictions themselves can vary and may rely on a few specific variables or just the behavior of the entire system being observed. For example, we could see that strong winds and high humidity usually precede rain. Therefore, when we see strong winds and high humidity, it is going to rain. Or we could see that in Singapore, it has rained more during December and January in the past, so that must be the case for the following years. Causal analysis is when we specifically look at a data set with the intention to find out what happens to a variable when another is changed. For example, if we were to use processes such as cloud seeding in order to prove that adding certain particles into clouds can speed up the condensation process and produce rain. Lastly, we have mechanistic analysis, which is like an extension of causal analysis. It aims to understand the exact differences in variables that make other variables change and are usually modeled using deterministic sets of equations. The example being the same as before, but we track specifically how much cloud seeding is required under specific and precise conditions in order to produce rain. Now that you have a general overview of these 6 types of data analysis methods, what would you say is the primary approach being used by MSS to forecast the weather? Let us know in the comments below along with 1 or 2 sentences explaining why you think that is the case.